Accuracy and precision. What are those terms? They're used a little bit differently in the general population now than they're used in chemistry, so we're going to talk about that just a little bit. Accuracy and precision are terms that are used to describe the reliability of measurements. You see here we have a balance we're going to be using in chemistry to take the mass of things, so we want to emphasize that these are used for measurements. So let's look at a question here. First of all, let's go and define what these two terms are. What is accuracy? What is precision? Let's first do accuracy. Accuracy is how close you are to the actual or accepted value. So that would be accuracy, how close you are to the actual or accepted value. Next, we have precision. Precision is how consistent a series of values are with each other. For example, if it's done over and over again, are those values reproducible? If you get the same value each time. So we're going to look at a question to try and examine this. Let's say we have this blue solid in an evaporating dish. We want to know its mass. And the blue solid is actually called copper sulfate. So what's the mass of the solid copper 2 sulfate that's in this evaporating dish? What we're going to do is look at a series of measurements. Then we're going to first try and determine are those measurements accurate and are they precise or some combination of those. There we have the copper 2 sulfate. We're going to see if it's accurate or precise. So let's first look at our measurements. The first measurement was 1.49 grams. The second measurement was 5.00 grams. The third measurement was 0.50 grams. The fourth measurement was 7.25 grams. And then the final measurement was really close to that, was 7.24 grams. Well, first of all, we want to see, are these accurate? To know if they're accurate, we have to know the actual mass of the copper 2 sulfate. So let's say the actual mass was 5.00 grams. With that, we'd say the first measurement was not accurate. It was not close to 5 grams. The second measurement was right on the money, so that definitely is accurate. It is the accepted value. The third measurement, for some reason, they were off by a decimal point, so that one is once again not accurate. Now, the second two measurements were a little bit high. I think what happened in those two measurements is they forgot to subtract the mass of the evaporating dish in which the copper sulfate is placed. So for both of those, we'd say both those are not accurate because they're not that we don't have a mass of 5.00 grams. Next, are they precise? Do we get the same number over and over again? We see, looking at all those values, 1.49 was only answered once, so that is not a precise number. Even though 5 is a correct answer, only one measurement gave us a 5, so that measurement is not precise. Now, the 0.5 was only obtained once, so that's not precise as well. But we see 2 times 7.24 and 7.25. Since we had that multiple times, if a person got that once again, we could consider those last measurements with each other as being precise. If you're looking at just these 2 measurements here alone, we would say that these are precise measurements. Now, if you look at those 2 measurements with all the others, we'd say all the measurements are precise, but those 2 by themselves would be considered precise. Okay, let's look at a couple of more examples here. Example is of a dartboard. Okay, so the bullseye represents the actual value. So this time, the numbers that were determined were not at the bullseye, but they were close to it. The second example, we had answers that were all over the place. And then the third one, all those answers are pretty close to bullseye. So let's look at accuracy first. We'd say the first one is not accurate because they're not at the bullseye. The second example is not accurate either. None of those reach the bullseye. Now the third one, they're fairly close, so we'd say those are accurate. Now, are these precise? The first one, we see those numbers are the same, even though they're not where they should be, and those are reproducible, so those are precise. The second measurement, we see those are not precise because they're all different values. And the last one, we see all those numbers are fairly close together, so we say those are precise as well. This brings to mind a couple types of errors that may be happening. Like in the first one, it'd be similar to forgetting to subtract the weigh boat or the evaporating dish. So that's what we call a systematic error. So in the first one, that would be a systematic error because there was some mistake made, but they made that same mistake each time, so they didn't get the correct value. The second error would be a random error because all the values were off, but in different directions. But the value you want to get is absolutely the last one we see here where it's precise and accurate. Look at that. If you have any questions, let me know tomorrow in class. Thanks.